Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so I think we're going to go ahead and get started. Welcome. And it's my pleasure today to introduce Andrea Stengel. He's at the German Research Center for Artificial Intelligence in Kaiserslautern. This is a DFKI, I guess? DFKI. Professor Stengel was going to be here, I guess, about a month and a half ago or something like that?
About 3 months ago. Already.
Oh, that long ago. Okay. So, unfortunately, he wasn't able to make it then. I think you were ill or something or another happened. But anyway, he's here now, so this is fabulous. And in particular, on a personal note, you may know something else about him, is that he's the advisor of the star intern of mine this summer, Georg Buscher. So he's a student of Andreas. So anyway, thank you, and I'll turn it over to you. This is Tools and Strategies for Building the Semantic Desktop.
Thanks a lot, Ed. Thanks for coming today. I'm glad to be here. So I like to move, not staying here. So it's better for explanations and gestures and so on. So today I'm talking about the Semantic Desktop. It's a bit derived from the Semantic Web. I'll give you an idea about that later on. But before, I'd like to ask you, well, maybe from Georg, you know something, but who knows about DFKI? Oh, you know, some of you. But, well, let me give a very short introduction to DFKI, because it's a very special institution, not because all of his research, but because of his organization. So DFKI was founded about 20 years ago. So at no later point, you can see it was in July 1988. And it was based on a competition of the federal government as a reaction to the fifth generation programming systems in Japan, and also on MCC. And the federal government intended to found the national center to focus all research on AI on one hand side, and on the other to build something which is going to transfer to the industry. So they thought about not founding another Fraunhofer Institute nor a Max Planck Institute. You should know these both directions, but to do something different. And they asked for proposals, and so many cities compete at the time, from Hamburg to south to Munich. And finally, a decision was made that the institute is founded in Kaiserslautern and Saarbrücken, but it's founded as a non-for-profit private research company. So which means that the main share is given to the industry, and they should take care that after some years the institute is running by its own. So at the starting aid, the government gave some money and only said at the time that 5 years should be enough to make the experiment, and after that the institute should run by its own. So today we have a third site in Bremen, which is founded in 2005, and since last year we also have another site in Berlin, because our federal government had the idea that we should be present in our capital. So, however, as I told you, as a private company, there were shareholders, and when DFKI was founded, the condition was that companies had to prove that they do research on AI. And at the time, late 80s, you can imagine, there were the traditional suspects, so to say. There was Siemens and IBM and Philips and AEG, which had a tremendously good research organization at the time. And there was Mannesmann, maybe different, but there was also a German company called Nixdorf. Maybe some of you remember, a very successful company, was the first SAP, so to say. But as you see today, there's a new generation of shareholders, including Microsoft, Deutschland, Germany, of course. But however, these are very good partners now. They are giving lots of research contracts to the FKI, and therefore own some share, while all of them have the same share. Yeah. The FKI grew a lot, So today we have more than 310 full-time researchers which are employed, and another 300 part-time researchers. Most of them are students, many interns from other countries, and it's still growing. This year again it's growing, and well, there are some customers, just a short collection, they ranging from the United Nations in the US, from Google, from Apple, Microsoft as well, SAP, and then to Japan, many Japanese companies like Sony, Ricoh, or Hitachi are customers of DFKI. Some results, because I told you DFKI is a transfer institute or company, whatever you like, because we are just in between. So I'm also a professor at university, and all the directors of DFKI are professors as well. So that's a bit strange. However, transfer means transfer to the academic sector, but also to industry. So we should consider both. And all 5 years we are strictly evaluated by the federal government. And this is a kind of intermediate result right now. There are 45 professors up to today coming out from our staff. And we are belonging to 8 networks of excellence in Europe, etc., but also from the economic side, because we are not working directly at the market. One of our missions is to provide transfer in terms of spin-off companies. And right now there are 42 companies. There are another 2 which will be founded very soon. And for that reason we received the German Spin-off Award in 2004. And that should it be about DFKI. Maybe now you have an idea about who we are and what's our mission. And today I'm talking a bit more about our scientific mission, the Semantic Desktop, because this is a very important and growing segment of how to provide a way to semantically interact with information, or how to implement the semantic web, whatever you like to tell it. And I give you an idea about what we think should a semantic desktop be, how we could build it, because it's not so easy to do, so we need to implement several strategies, and also how to integrate paper documents, because I worked for Xerox in the early 90s, and you know about the paperless office. You're going towards a paper-poor office, but we still interact with paper a lot, and this is not in our community, but if you go to industry, they have a lot of paper, and it's a matter of fact that we need to integrate paper into this consideration. And finally, I sum up and show you about what we are intending to do in the future. So what is the semantic desktop? I first start with a kind of definition we gave, that it's a device in which an individual stores all her digital information like documents, multimedia, or messages. And these are interpreted as semantic web resources, so it's a unique identifier, URI. And all data is accessible and queryable as RDF graph. Resources from the web can be stored, and authored content can be shared with others. And ontologies allow the user to express personal mental models as their own way how to consider information, and thus form the semantic glue interconnecting information and systems. Applications respect this and store, read, and communicate via ontologies and semantic web protocols. The semantics desktop is, so to say, an enlarged supplement to the user's memory. So what do I like to say with that? This is just a result of our research we do on social network analysis. This shows the blogs, the 100 most important blogs in Germany, how they are interconnected. And this is just a small fragment of the whole internet. And if we consider the internet, the web is our primary means to express, to give information to others, to society, to our taxonomy. And nearly everything we find in the web is input by the human being. However, it's very hard to interpret the contents of all these information items. And therefore, many researchers in the world, including Tim Berners-Lee, intend to represent semantics of all the information to make the information better understandable. But there is a big problem. And the problem is, how could we find a respective vocabulary to all the people? How could we speak about the same? Because people have different roles, interests, backgrounds, educations, projects, whatever. And I'd like to give you an idea how we could solve such a problem if we start from an individual consideration of information. So finding the right vocabulary is difficult. I give you this example here, showing you the 4 fruits, and I want to ask you to categorize them in 2 categories. Maybe you can help me. Well, other green, red.
Sweet and savory.
Good.
Round and not round.
One with stick, without stick, the one I like, I don't like, the one I bought last week, the one I didn't. So there are many ways to express the view to information. And this is a very simple example. Yeah? And if you see the daily practice working with document, it strongly depends on your specific situation about what you currently are doing. If you have time, if you have no time to work with information. If you just consider a document and you would ask a lawyer or a serviceman or a technology guy, what is the contents of the document? It's different. So people think different. And it's if you go to the situation in the office, people use their own vocabulary to express what information means. And in major companies, class categorization of information is hardly supported. Yeah? And if you just take the source of the Delphi, there's a Delphi report from 2004, and they showed who classified the information. You can see that most of the information is classified by an individual. Because individuals tend to use their own organization. Yeah? Because the organization represents their own world of information, which is easy to use for them. So I want to state some theses that, first of all, the bondage of formal organization of information inhibits creativity and limits the options of self-organization. And second, the document is not just a piece of paper like in the past. Today we have a very dynamic object of multimedia contents, which is changing over time. Yeah. So we need a new definition of an archive, because the individual drains of thoughts, they always drive the interpretation of the contents. Yeah, so we have very perspective views to the contents, depending on our demand in a specific moment or because somebody calls us and so on. So if we consider even single terms expressing what we mean, it's very hard for us to transfer the meaning to other people. I want to just take a statement of Immanuel Kant, which is a very famous philosopher in Germany. He talks about imaginations without terms are blind, and terms without imaginations are empty. So if I would tell you something you have never heard before, you could not understand. And if I have something in mind, I can tell you can't see it. Yeah, because we have imaginations, associations in our brain, and we cannot send it via the air to other people. Yeah? We have to do abstractions via the language. And if I would tell you about my daughter, of course you know what a daughter is, but you don't know whether it's a small kid or a young lady, or how she looks like, because we need all this contextual information when we talk about this. So, and this is very important for the interpretation, and this is always reflected within our mental models. And mental models is kind of a representation of the past, where we hypothesize and test all the situations we have in mind and try to reflect the situations to our knowledge. And that's what we do at our workspaces. So in the office environment, we classify documents according to our specific preferences. We establish folders and give name to the folders, and these folders represent our very perspective view to the world. And so if we have these taxonomies available, these taxonomies, however, have no unique meaning. Yeah? Assume I would take a folder, and I have a very common example, like with the name vocations. Yeah? So I store all the document inside about my preferences to vacations maybe, so I have something in mind. But if I would just tell the term vacations to somebody else who has plans, yeah, who just came from vacations, she or he must think about something different. And that's the situation in the office today. If I want to have a look into the taxonomies or directories of my colleague, yeah, because he or she is absent, it's very hard for me to understand what's inside. So this is because we think different. On the other hand, these taxonomies are also allowing perspective considerations. Assuming you would ask me, I know I gave it to Henry, you would ask me for my slides and I would send you an email with the attachment of my slides. You have to ask you, where should I file them? Because on abstract layer, information has a who, a what, a where, a when, etc. dimension, and you could put it into talks, into a new one, maybe my name, and to MSR and Semantic Desktop, whatever, and you have to question where to file it best, because you have to remind someone. But depending on the situation, you sometimes has to ask for a who, yeah, or sometimes you ask for a when or for a where, and then you have to remind yourself in which folder you put it, or you have a good desktop search, yeah, whatever. But beside this, there's a third issue which is of importance, that there is no integrative view to information based on this taxonomical organization, because we have, of course, our file systems where we have the folders, but we have also our email folders and maybe the bookmarks, and all these worlds are separated. There's no way to really associate the information. So many people, believe it or not, we did some studies, they copy the information, put them in different folders and different worlds to be sure that they refind it. Yeah. So based on these considerations, we first of all developed a specific interface called the personal memory. And this personal memory allows you to store information with respect to different views at the same time. So this is not a physical file of information, but a virtual filing. So we are able to just mirror the Explorer in this personal memory, and at the same time we could define appropriate or additional views to information, like here, unfortunately it's in German, we have the document view up here, there's the partner and customer view, there's the organization view, there's a topic view and the project view. So you could put single files in different folders. But the good thing is here you could apply information retrieval technology to really analyze how users consider information. So how do they cluster information in single folders? And so everything the user is doing is recorded by the system, and all the folders receive a kind of profile representing the mental model. Think about vacations. If I would ask you, what do you think if I would ask you for vacations? And maybe you think about palms and beach and sea and whatever. And this is very similar here. From the interpretation, of course, there are mainly statistical methods, but what we can store is a kind of electronic mental model for each of the folders, explaining the contents, because all the documents are considered to belong together. So the advantage here is that based on that, we could not only store documents with respect to different views, but if new documents arrive, the system could guess about the relationships, associate the contents of the documents to the different views. So this is shown by these question marks here. So that a document proposes and asks you, do you like to store it or to file it within this virtual folder? And you just say yes and change the question mark to the hook. And as soon as you do that, the profile of this folder is changed. So the new document is added, and the system learns over time more and more about your perception of the world. Yeah. There are many different retrieval techniques included, like user feedback with the plus and the minus if the system and many others. So it's explained in the paper if you would have a look more deeper to this technology. So up to now, I want to summarize, there are some advantages of this basic approach. This is that the contents of information objects, whether it's a single document, whether it's a terminal or a non-terminal folder, are expressed in the same way. So we could compare documents with folders and with higher order folders at the same time. And the communication between the user and her or his personal model is driven by conceptualizations, allowing to communicate with your system on the same layer of your mental models. Because the system helps you to associate terms in the context of a meaning. So it's very easy to understand your system in a better way. And if you combine it with the perspective directories, the user also gets an excellent orientation and access point to the information. However, there is not yet a semantics, and there are only implicit relationships among the informations and the terms. And our idea is to have more expressiveness in this system, and we are considering this system as a vehicle to go towards semantics. And I show you an example of how this can be seen. So assume you are in an insurance company and a document would arrive, and you have the choice to store this document in different information dimensions. For example, you have a dimension of different document types, so offers, invoices, and whatever. You have different contacts, about persons, you have events, and you have cases, and the system would just guess, because of the experience it has of your earlier filing, that the document may belong or might belong to different folders. So I just enlarged some of them, so we have certificates, notification of claims here, we have different contacts, we have one event here, an accident, and we have cases like car damage. And so as soon as the user would change the question marker to a hook, the system could use implicit pre-given generic relationships which are generated on the fly. For example, that this document is a notification of claim. It further is generated by a specific person, or it describes an accident, or furthermore, it addresses a car damage. But you could do even more. So assuming that the document is belonging to two dimensions at the same time, you could further initiate a relationship like the person also declares the accident, or that the accident implies the car damage. And so along the workflow, other documents could come in, and the documents are then certificates addressing all the same subject generated by a different person, addresses the same car damage, and comments on the accident. And they are just generated on the fly while the user makes his hooks. So as a result, we obtain a representation which is compatible to the semantic web. Everything is considered to be a semantic web resource using the URIs. And so we have different resources like email here with the IMAP address, with the PDF, with a file here, file document, or a website. And all the resources may be categorized as an event, a topic, or an organization at the same time. So you have some categories. So RDFS, so schemas which are pre-given. And in a first setting, we are not looking as a kind of general framework, but we are still with the user. So because we have this personal view to the information. So we consider a personal information model in the first step, not yet an ontology. So as an example here is, consider my talk again, which is filed in some of my folders. So we have the URI of this talk. And I could categorize this as being a talk. And it's held at a specific place, so which has a website. So I have another URI. And I could say that this is an organization. And this talk is hosted by Microsoft. And this is also an organization. And there's a chairperson. Yeah. And there's another one who's giving the talk. And both of these are persons. And while Ed is working for Microsoft, I work for DFKI. And DFKI is another organization. And maybe I have a trace of Ed in my Outlook system. So I have another URI which is connected. And I also could make connection to my calendar system. So everything could be connected via this approach, and we are generating triples on the fly, and therefore connect our native resources with all the applications on our PC. Yeah? And generating step by step this PIMO. And so we have a hierarchy of PIMO classes, categories, represented as RDFS. And we have a mixture of these classes and the entire instances on our PC. Yeah? And so step by step, the user is able to generate more and more semantics, please.
What's a triple?
A triple? It's an RDF representation where you can think about subject, verb, object, or subject, predicate, object. So use, for example, a URI, any predicate given, like in the example before. So this is a triple. This is a subject, and object, and this is the predicate in between, and you could interconnect many of those, whether it's an entire resource or it's a class. So the good thing is that step by step you are enhancing the semantics within your workspace, and you could also share the resources with others. For example, you just make them public, you make them accessible. If you're an expert on specific fields, you could just give parts of your PIMO to other people. Yeah? And there are also techniques to avoid the use of different syntax, talking about the same thing. This is called smushing. There are several approaches to avoid this. You have just a representative, which is normalized from different syntaxes, and then guarantees a kind of semantic identity of this. There are some sources you could read, or references you can read about all this.
What does it mean to share a PIMO? Does it mean that you're sharing the objects as well as the relations, or just the RDF?
It depends on what you want to do. So you could first share your PIMO on the layer of URIs, but as soon as the URI is visible for the other person, it's accessible for him or her. So you could share the resources as well. So the model, but also the resources. Yeah.
And the relation types that you had in the previous slide, like relates to or describes, are those part of pre-existing RDF ontologies?
Yes, exactly.
The verbs are
Yes.
specified?
Yeah. You should try to normalize the way how to use relations. Because if you have say a closed environment where people share information, you have to predefine these somehow. So our intention is to really find out from the PIMO what kind of relations, this is another work I do not present today, what are the most common relationships people use in specific environments to build extracts out of this, and do something like a pre-configuration of relationships which suit to a specific application. So to learn from people when doing so, I come to this later based on Web 2.0 issues, but then to learn from this and to build a kind of a basic framework for the people who can use it. Yeah? So yes, so our first step is to build a semantic desktop where you have a personal assistant at your workspace which step by step learns about what you're doing, what your preferences are, and who works in the background and giving advice, connecting documents with applications, and so on. The most important thing here is that we combine this with active user observation, and this is some relations to Georg's work. I come to that later, because our intention is also to see in what context people work with what information items. How do they use those items in a specific way? And there are some benefits out of that. For example, that incoming emails are tried to be classified by the system, that a email coming in here is about the topic ontology, or is about reviewing specific papers to a conference called WM01, or that this email refers to the DFKI department knowledge management. So the user could just accept the proposals or just do another one. We also implemented a so-called Dropbox, which is applied or employed as soon as you do a save as. The system makes proposals based on that what you already did, in what categories the information should be put in. And this is another very nice example about context-aware services. It's about observing the user in the active window, which means assuming that the user would just browse here on this web page, we developed a nice sidebar which offers, first of all, a common search, but more than that, it offers all tasks the user is working on, all data sources and concepts, and more specifically, it shows all current tasks which are related to the contents of this web page. Or it shows all context-relevant information items, or all categories which might fit to the contents, or the persons and the projects. And moreover, you could also relate the contents of the web page by a link which says that the subject of this document is the project Nepomuk. You can see another triple here, which you could define interactively with the system. So you combine traditional IR with the semantics of the internet. And there is another example we developed. It's called iDocument. And this is on a combination of Web 2.0 issues like this term cloud here, tag cloud. But it also guesses about the contents here, what persons could be related to the contents, or what organization items, what projects, what topics. So you can see the different sizes of the terms here because of the importance, and moreover because of the information items, the entities found. The system also proposes triples. For example, it founds a project called EPOS. It's shown here at the beginning, and it also found persons like Björn Feuscher, and the system guesses that EPOS has project member Björn Feuscher. So it's just a proposal for the user. Instead of typing everything in, it just make a hook. He or she could just make a hook and then accept the proposal of the system. So on the fly, you could again collect semantic relationships. So we are using also some of the web services here within the system. And this is about semantic search. So assuming you have this PIMO model at the end, you could also combine this with semantic search, where you could type in a term like veto. It's just a string, and the system guesses that there are some persons related to that string, some projects, concepts, and events maybe. There are more than that, but just I'll show you 4. And with the search results, you could have direct access to the resources again. So you can see this is an Outlook entry. And the more important, the system also finds another person, Bertine Klein, which has nothing to do with this veto, but because we use Sparkle rules in the background, which, for example, here says, if you found a project related to that, show also the different other project members. And so you could assist the search by using semantic derivations. This is also an addition we just developed. This is a context-sensitive dashboard where individual person could retrieve specific situations. This is based on the assumption that usually people work on different tasks at the same time and you have lots of interrupts. Yeah, because the phone call is coming in and the phone call implies to do something different. So you change, you start with something going on, and this helps you to retrieve all the active windows related to the situation you just you skipped, or to come back and to see all the relevant information at the same time. So the Semantic Desktop is built on a aperture crawler. This is a system developed by DFKI. It's an open source platform where you could combine all native sources, and we have a Sesame 2 repository with a PIMO store, resource stores, and others. And then we have the Gnosis server. This is part of the Semantic Desktop. And on top of that, we have different semantic applications via web interfaces. And coming to that later, this is all open source. So you could just look at our webpage, open DFKI, to load some of these applications for your own. And we also use some annotations within applications like Outlook or like Mozilla and others, where you could just easily browse and link resources together. And coming to a very important aspect is if we are still dealing with paper, how could we integrate paper into this philosophy? And we have different approaches to that. This is just using a desktop camera, which has about 300 dpi, so about 3 megapixels. And this camera projects, I'm not sure whether you can see, it projects a laser frame on your desktop. And you could just put some documents in there, click, and you have the image on your PC or laptop. And then we combine it with OCR. Yes? Yes. The company is called Sky. You can have a look. And then you got the OCR results, and this is then transferred to a semantic wiki we developed. And in the wiki, we show not only the recognized text, but furthermore, we also show the recognized entities. So these are part of our PIMO model. And if you click, you directly go to the URI. Yeah? And the nice thing here is that we again thought about how to collect information from the resources, how to expand the PIMO. And this is done by this single-click entry, which allows you to have a predefined kind of categorization scheme, for example, persons, organizations, event, etc. And as soon as if you move the mouse into this window, you see the small flag here. And depending on where your mouse is, for example, if you look for places, you just go to the words, click on that, and you can collect new instances of places, for example. And furthermore, you have a kind of semantic indexing of the resources at the same time. Yeah. Another approach we follow is using the IPAN, and based on the Anoto pattern, because many people tend to still read on paper because it's a good interface to your brain, having lots of interactions. And so we are using the Anoto pattern to sometimes print paper, to print documents out on the Anoto paper, and then using the IPAN, which is staffed with the camera and a pressure sensor, and then we do interactions on this paper. For example, not only the annotations, but also some gestures, some written gestures, while the gestures indicate semantics. So we can again combine the PIMO with the text on the document. Yeah. We're also now developing a Anoto tabletop, where we use Anoto paper with a beamer on the, just a single beamer on beneath it, and then we do interactions right on it, and so on. There are some applications we have in mind. And now coming to user observation, I already told about that's very important to see what documents are used in what situations. And because of these devices today only have limited ways to observe what users are doing, we thought about how to develop an interface to brain. And this is not very easy. Next year we will start with the EEG measurement, but the more straightforward approach was just to use the eye, because the eye is an excellent interface to the brain. And so we combined eye tracking. There's a company from Scandinavia called TOBE. Maybe you know. I've heard from Georg you have an interface. We now bought a screenless eye tracker. You also bought maybe, I'm not sure. But the idea is not only to see those heat maps or heat maps, but also to see how intensive people read information on the screen. So, and this is very important when solving specific tasks, because we can store the information of this eye reading combined with the intensity of the different passages in order to collect best practices. Yeah? If you, for example, would do a proposal, write a project proposal for a specific federal institution, and you now know how to do it, maybe there is another person who does not know, and so the system could give some hints about what information is used to solve which task in the whole process. Yeah. And this is a very important fact to do so. And coming to the chances of this approach, finally, I first like to sum up, because you see the shift of the web from the traditional web towards the web of people, and we have the other shift of the web of meaning. And the focus today is on communities, on taxonomies to have collective wisdom to solve tasks. And we think that the Semantic Desktop is not only a driving paradigm, but also a very nice tool, instrument to implement Semantic Web on your micro world of the desktop in the first step. And because we have these friend networks where we have trust, project teams, departments in a company, or interest groups, whatever, you could share these semantic information with the others at the same time. So we think about these two dimensions, having community relationship as one dimension and the semantic foundations as the others. And you will see the shift towards Web 0.0 and the web towards the semantic web. We think that the Semantic Desktop could be a nice instrument to further reach higher semantics or more semantics of the information. There's also a nice paper we just finished a couple of months ago. And we also succeeded in getting the largest IP, so integrated projects of the 6th framework in the EU. It's called the Social Semantic Desktop. And this is an open source framework which could be used by everybody. And this is now going to provide a mechanism how we could share the PIMOs with others and how to socialize them in order to build real ontologies. Yeah, it's going a bit more into how ontologies could be mapped and merged, based on the individual PIMOs, how we could build extracts as expert knowledge, assuming you are, for example, let's think about the insurance companies where you have different experts working on the same topics, and they have their own PIMOs. How could we build a kind of sustainable piece of knowledge which could be given to a newcomer, to a freshman joining the company as a kind of starting, which could be used by her or him. So there are many partners in this project, and this project will finish end of this year. And we are now going to develop very nice interfaces, and we like to spin off some new companies based on that. And we'll see how that works. And so thanks to my team, and thanks to you for your attention. And if there are questions, I'm ready to answer them. Thank you.
Can
Yeah.
I ask about the ontology over time. So I actually very much like the notion of having lots of different attributes and being able to browse by them. But if I now decide to organize, we'll say, a file hierarchy that has single class membership, and I rearrange projects, I then move the files to the right projects, and it's over. If you have back pointers to those objects, it's hard to know how they should get reorganized.
That's right.
So the question is there any, in general, is there any way for dealing with the evolution of these ontologies over time for things other than simple containment relationships?
Yes. Well, this is a very difficult task, and we have two approaches to that. As each memory, such a memory should also forget. And the question is, how should the memory forget? And so we are going to implement a kind of timestamp. If a document is not used for a certain time or has a certain age, it will pop up and ask, do you need me again? Or do you need me once more? So you could just change the timestamp to another, maybe in the time in the future. And the second issue is that we just started a new project about validity, whether a relation still holds or not. This is a very important fact. And we just started, so we have different ideas about that, because we also like to use some kind of trust technology from the social network analysis domain to evaluate those. But a complete solution is not yet available. Please.
What kind of learning algorithms are you using for Semantic Desktop?
Well, basically statistical methods. So we use different methods at the same time. We have support vector machines. We have Rockio methods. Maybe a good idea would be to just see our OpenDFKI website. There's a tool called DynaQ. So it's a very rich, very powerful retrieval engine, which is used also in the Semantic Desktop. It combines all state-of-the-art technologies in information retrieval. It's basically built on Lucene, but it's enriched by many things, including also dynamic search. We have sliders, so you could have a in-between weighting of the terms and many nice features. So please look at it and download it. Ed?
Well, I wonder if you could talk a little bit about how you encourage people to apply these semantics in the first place. I mean, whenever you showed your systems of all of the different things up there,
right.
It looks quite overwhelming, and it seems one of the key things you have to do is to get to actually apply the semantics.
Yes, that's not the easy thing to do. First of all, we are tracing knowledge workers. So we also did some first case studies in insurances and in retail companies. But if you see traditional users of Microsoft systems, for example, they are overwhelmed with relationships. They like to have a very lightweight, easy way to categorize, and they accept some weaknesses of the system in retrieval because they want to avoid complexity. Yeah? So they rather invest time instead of having higher ordered relationships between different information items. So we basically address knowledge workers, and we see the tendency based on the internet deployment, how they use the internet, that knowledge work is very much increasing in the future, so that people will join virtual teams which will have very high qualification to specific things, and they need tools to really orient themselves to navigate through information. So there will be a difference between people who could use the systems very soon and those who should wait for more lightweight interfaces. And usability is the thing which is of high importance for the future, how to build those things. Yeah?
I have a question. I think it's different from SUSE. I've done some stuff with building graphs over knowledge resources, and one of the things that was really essential there is that links have kind of a time bound, or some links do. Like, Ed doesn't, you put up this link that says Ed works at Microsoft. Well, Ed doesn't work at Microsoft. Ed started working at Microsoft on this date. He happens to be working at Microsoft now, but he might not be working at Microsoft in the future. So that's one aspect of links, that kind of time boxing. Another is that the entity that made the assertion about Ed working at Microsoft, and when that assertion was made and what evidence supports that assertion is important for traceability and trustability of that knowledge. And if it's just a link in a database, that doesn't have that traceability. But how can I be confident in it?
All right. Well, from my point of view, it's a very similar situation like for Wikipedia. Yeah. So that many people share this resource and many people contribute to that resource. And not everything people would put into Wikipedia is the right stuff. Just if you see all the contributions made for George W. Bush, you see different fractions of people who want to tell this one and want to tell that one. So I think at the end you need a combination between detecting whether things still hold or not. So a system could propose, for example, relationships, and the user would observe, well, I'm not sure whether this still holds, but you need a moderator, so a qualified person who finally would decide what to do. Yeah. So if Ed may have left Microsoft some time and you would see this relationship, you could just send it to a moderator and say, please check.
In the underlying representation, is there room for that accountability information?
Not yet, but in Germany we started a very large project called Theseus. So this is the name of an ancient Greek king, but this Theseus project is focusing on semantic web services. And one of the topics there is to qualify information. So we like to integrate measurements about trust, about how to compare services on the web, respecting specific problems. How could we apply them? And in this consideration, we will have some options to represent this. So we are enhancing the just semantic representation by qualification of information.
If I may add on this, this is a popular topic for discussion in the Semantic Web community, and I've even disagreed with Tim Berners-Lee around this. His solution is the concept of reification, which is representing the relationship between entities as a resource itself. And if you represent it as a resource, you can attach attributes to it, like this statement, the person who works for Microsoft, was made at that particular time and has duration. So you can represent now a graph around the relationship. Another approach that we support and I particularly like is, rather than having triples, you have tuples, where every relationship now can have its own properties. So you can qualify the relationships as you apply them between objects. And therefore you can add the additional things that we say. Both approaches have the negatives and the positives.
Many people think about both approaches at the same time, having triples and have a complementary tuple representation about specific properties. Please.
I love this idea of removing the disorganization of information that I struggle with on my desktop. Things are so jumbled up, and it's really hard to switch context because information persists visually in other ways, and I find myself cognitively distracted by that lack of organization. So I love the idea that you can abstract the user's memory in a way that powerfully allows them to reorganize their information experience. I find that an extremely compelling idea. The thing I struggled with was, first, I kind of agree that the complexity of the categorization system seemed a bit overwhelming. And then second, I also felt like personally, my categorization tends to be very it's very relevant to speak of those 2 points. To the point in time at which I made the categorization. Yes. It's like a week ago I recategorized my email, and 2 weeks later I've kind of forgotten the reason I did that.
Yes.
My priorities have changed. And so I struggle with this whole idea of, I love the goal, but I fear that the explicit nature of categorization is just bound to create a fragile taxonomy that within a short period of time just adds complexity, becomes irrelevant, and is a pain.
Right. Oops. This is something I have to talk a bit more about. Oops, next one. Here we are. So tell a bit more about the functionality of the system. You are right that users change their thinking because there are new topics arising, new projects, new people coming into the team. And this system in the first view does still avoid semantics. It's built on implicit relationships for the first thing. So this is just a platform to build relationships on the next layer, because we are integrating now kind of generic relationships between the folders. But you are right that things are changing, and therefore we have some cluster algorithms in between. So for example, if the topics within a folder are going to be too heterogeneous, the system pops up and tells you, I would split this folder in two subcategories, and also proposes some placeholder. So the most important term of these two clusters. So the user again can think about, maybe I should change the organization. So the system is a kind of assistant, which helps the users to really keep track about the changes as well. And what I didn't mention also here in the system is that the system also allows you to publish folders without giving the documents to some people. Because we also we detected that people avoid to give the documents out to others because they don't know exactly what they would do with the documents. So this is a kind of psychological hurdle to really come over. And so we have, with the right mouse click, you can just go on the folder and you can publish the profile of the folder without a document. So if people would search for specific topics, say for RDF, for example, and I would have published the Semantic Web folder, I could be shown as being an expert for RDF, for example. At the same time, documents are shown to the user. So, and then can I use a chat room that people could connect me and ask me, well, could you give me some information about this? And then it's kind of explicit. If I would publish everything, I do not really record who is taking the documents away. But that way, I'm available as an expert in the network of the company, and people could come and explicitly ask me for the documents. So there are many features. So if you like to see, have a look in the paper. More questions? Please.
You had this very interesting discussion about paper and how important it is, and how I love paper and reading on paper. Do you think that digital native people who are more used to reading online and on screens are have less profound need to associate with paper? Do you think that behavior is changing?
It's interesting, because I think there is a trend. If you see the people who are working more and more with computers, they are wanting to use paper. So it's really going towards a paper-poor office. But I think both media are very valuable. And therefore, I already mentioned to Fabrizio that I'm waiting for the electronic paper. And there are two ways to consider electronic paper. The one is just to use Anoto patterns, for example, to have the common paper as an interface, and the other one would be to have a very lightweight interface where you could really interact, not only display information right today, but we have both in mind in the focus to develop new technologies to interact with both media at the same time. So I think the pen and the paper is a really direct, say, multi-sensoric interface to the brain. So it's very important to have a pen and to work with the pen with information. There are very interesting studies about this. So you can be more creative instead of just typing. And therefore, I think in the future, electronic paper will be a very important interface. Okay?
All right, thank you.
Thank you very much.